Our next topic is called apportionment. So apportionment has to do with, say, taking 50 representatives and dividing those up into various, say, states. So for example, let's say that there's 1,400 people in Donnieville State. Maybe there's a little over 2,000 in Addyville, and then that's a slightly bigger population. Salina City is huge, and then Joe Burbs is a suburb of Salina City, and it's about 11,000 people. So the question is, if we're going to have 50 representatives for this country, and we're going to give those, each state gets a certain number of representatives, we obviously want to make sure that Salina City has the most. And so I'm just going to see if this works. What if we gave 3 here, 4 here, 5, 9, 16, and 13. Right, you can see that all of these values add up to the 50 representatives. They do add to 50. We've given the most to Salina City, and then our smallest population of 1,400 gets the least number of representatives. But these numbers are fairly arbitrary, and also someone might complain. Someone might say, hey, Joe Burbs has 7,000 less people than Salina City, but only 3 less representatives. That's not fair. You know, they might say, hey, they only get 3 representatives. I deserve more. You know, so we have to have some sort of a mathematical way to come up with splitting these 50 representatives fairly among these states. So we do have 4 different methods, okay? After we do this, we are done with the content for Math 101. Here are the 4 methods. We've got Hamilton's method, Jefferson's method, Webster's method, and the Hill-Huntington's method. During this video, we're going to talk about the first method. And of course, these are named after presidents or the people who have created the method. So this is a chart here, and you should get familiar with this. You'll see this on a test and a final. So we're basically saying that we have 20 representatives, and we've got a state called State A, a state called State B, a state called State C. And we're trying to figure out how do we split those 20 representatives, right? Our final answer will be down here. Don't write this down, but maybe it should be something like, I don't know, maybe 15 here, 3 here, and 2 here. But someone might say, that's too many for State B, right? So we have to come up with a mathematical way to do this. And let's learn about Hamilton's method. First of all, we need to add up the population. So I need to do 370 plus 500 plus 130. So that gives me 1,000 people. Now, the standard divisor, that's this right here, let the standard divisor be equal to the population divided by the number of seats. So we're going to take our population of 1,000, we're going to divide it by the number of seats, which in this case is 20. So 1,000 divided by 20 is 50. So this is called our standard divisor. It's really helpful. Then notice for this, for each state, our standard quota here, we are going to do the state population divided by D. So I'm going to take 370 and I'm going to divide it by 50. And then I'm going to take 500 and divide that by 50. And then I'm going to take 130 and divide that by 50. So we're basically taking each of these things and dividing it by 50. So let's do that. So 370 divided by 50 gives me 7.4. 500 divided by 50, that gives me 10.0. And it's nice to kind of put that 0.0. And then 130 divided by 50, that gives me 2.6. So the minimum quota is going to be basically exactly what you have, but you're going to drop the decimals. So for example, I'm going to say that the minimum number of representatives this state A should get is 7, right? I'm just dropping the decimal. For B, we should just have maybe 10 and then drop the decimal. And here the minimum is 2. But adding these up, look what we have here. We have 7 plus 10 plus 2 is actually 19 representatives. So we're close to getting to our 20 representatives, but we're off by 1. So what Hamilton's method does, it makes you keep track of the fractional remainders. So what is 7 minus a 7.4? Well, that gives us a 0.4. What's 10 minus 10? Well, that's 0. And what is a 2.6 minus 2? Okay, that is going to be a 0.6. So now we need to distribute one more seat. And who is that going to go to? Well, we're going to distribute the remaining seats according to the size of the remainders until the surplus of seats is exhausted. So I have to give an additional seat to someone. And who am I going to give that to? Well, I'm going to give it to the person whose decimal is the highest, that 0.6. So I'm going to keep this at 7, keep this at 10, but I'm going to change this 2 right here to a 3 because this decimal is the highest. And now we do have that add to 20. Now, just keep in mind, folks, that if this was, say, something like 18, we would have given 1 to both this one and to both this one because those had the highest fractions remaining. But we only had to lift 1 up because we were at 19. So that's it, folks. That's how we do the Hamilton method. As a reminder, we add up these values first, and that gives us our total value. To get our standard divisor right here, we take our 1,000 and divide it by 20. To get these values in this row, we're going to take 370 divided by 50, and then we're going to do 500 divided by 50. Then we do 130 divided by 50. That gives us here. Then we just round down and we get rid of the decimals, and that gives us these values here. It also tells us how many seats we're at total, in this case 19, which means we would have to round one of these values up. So we keep track of our decimal remainders, and that's just going to be the 0.4, the 0.0 or 0, and 0.6. And whichever one has the higher decimals is going to get the extra value. In this case, the 0.6 made this 2 right here jump to a 3. And that's it. Now this adds to 20. But remember, if this one was, say, something like 18, you can certainly add an extra 1 to 2 of these states. And just make sure you're doing it in accordance to which ones have the highest decimals. Okay, that's it. That's Hamilton's method.